And good morning, Wolfpack, and welcome to lesson 4.9, Properties of Parallelograms. We are moving away from triangles into quadrilaterals and parallelograms. So let's get ready to shift our focus a little bit. Our essential question is, what quadrilaterals are connected to a parallelogram? So a quadrilateral is a polygon with 4 sides. Quadrilateral, think about quarters, it's 4, so 4 sides. The sum of the interior angles of any quadrilateral, no matter what it looks like, if it has 4 sides, the interior angles add up to 360 degrees. So then, a parallelogram is any quadrilateral that has 2 pairs of parallel sides. So a quadrilateral is any shape with 4 sides, but then a parallelogram has 2 pairs of parallel sides. So if it's a parallelogram, here are some properties or theorems of parallelograms. So if a quadrilateral is a parallelogram, if we know it's a parallelogram, then both pairs of opposite sides are parallel. Thus the name parallelogram. That means AD is parallel to BC, and AB is parallel to DC. Also, the same side interior angles, aka the consecutive angles, are supplementary. So if this side is parallel to this side, and it's being intersected by a transversal, this angle and that angle are supplementary. That means they add up to 180 degrees. So angle A plus angle B equal 180 degrees. If a quadrilateral is a parallelogram, then both pairs of opposite sides are congruent or equal to each other. So as you can see marked on the image, BC is congruent to AD, and AB is congruent to DC. If a quadrilateral is a parallelogram, then both pairs of opposite angles are also congruent. Or equal. So angle B is congruent to angle D because they are opposite from each other, and angle A is congruent to angle C because they are the angles that are opposite of each other. If a quadrilateral is a parallelogram, then both diagonals bisect each other. That means to cut in half perfectly, not just to divide up, but to cut in half perfectly. So as you can see, if I were to put a point right here, from B to the point is congruent to D to the point, okay? So they are bisecting each other, they're cutting each other in half. And the same thing, AC is being cut in half. So A to the point is equal to C to the point. They bisect each other. Or if a quadrilateral is a parallelogram, or if we know that it has at least one pair of opposite sides that are both parallel and congruent, then it's also a parallelogram. So one pair of sides is both parallel and congruent. You can see here that BC is parallel to AD, and BC is also congruent to AD. So since it has a pair that is both parallel and congruent to each other, then it is a parallelogram. These are 5 properties or theorems that you're really going to have to get familiar with, because you're going to have to be able to see, oh, wait a minute, I see that the opposite angles are congruent, that means it's a parallelogram, and be able to make decisions based off of that knowledge. So example 1, decide whether you are given enough information to determine that the quadrilateral is a parallelogram. Letter A, both opposite sides are parallel. That should say both pairs of opposite sides are parallel. My apologies. So both pairs of opposite sides are parallel. Let's look back at our properties. And the first property says both pairs of opposite sides are parallel. So yes, we have enough information to say that this is a parallelogram. And I'll just draw a parallelogram. I have a horrible one. Let's try that again. Eraser. Okay, if I know that this side is parallel to this side, and this side is parallel to this side, is that enough information? Yes, it is. The next one says that the diagonals are congruent, which means that the red line is equal to the blue line. Let's look back at our information about diagonals and see what it says. It just says that the diagonals bisect each other. They cut each other in half. It doesn't say anything about the diagonals being congruent. So I do not know. I know that the red line is cutting the blue line in half. So this portion is congruent to this portion. And the blue line is cutting the red portion in half. This piece is equal to that piece. But I do not know if the whole red line is equal to the whole blue line. That's not enough information to say that this is a parallelogram. So this would be a no. Example C, or example 1C, one pair of opposite sides are congruent. So if I know that this side is congruent to this side, is that enough information to say this is a parallelogram? Well, looking back, I know that I need both sides congruent, or I need one side to be opposite, one pair of opposite sides to be congruent and parallel. And this just says one pair is congruent. So no, that would not be enough information on its own to say that that's a parallelogram. And lastly, that the consecutive angles are supplementary. So this angle plus this angle adds up to 180 degrees. And if I look back at our properties, sure enough, it says the consecutive angles are supplementary. That's enough information to say that this is indeed a parallelogram. So yes, this is enough information. Example 2, can you prove the quadrilateral is a parallelogram based on the given information? Explain what theorem you would use. So on letter A, I see that this side is congruent to this side because they're both marked with 2 tallies, and this side is congruent to this side. Is that enough information to prove that this parallelogram, that this quadrilateral is a parallelogram? Yes, it is, and the reason is both pairs of opposite sides are congruent. You can write the shortcut for congruent if you want to. The next one says, I'm looking at the picture, and I see that this piece of the diagonal is equal to that piece of the diagonal, and this piece of the diagonal is equal to this piece of the diagonal. So it looks like the diagonals are bisecting each other. Is that enough information to say that this is a parallelogram? And yes, it is, because that's a property of parallelograms. Yes, the diagonals bisect each other. And lastly, I see that I have one angle congruent to an opposite angle. Is that enough information? Let's look back. And I need both pairs of opposite angles congruent. And I was only given one pair of opposite angles. So no, only one pair of, not off. Opposite angles are congruent. So again, these 5 properties of parallelograms, you're going to have to get really comfortable with them, being able to look at a shape and how it's marked and deciding, yes, this is a parallelogram, or no, it's not a parallelogram. We will do examples 3, 4, and 5 using this knowledge to algebraically solve some problems about parallelograms. If you have any questions, please make sure you write them in your margins and ask me next class. Have a great day, Wolfpack. See you next class.